All right, so where to begin? It's been a long time since I've kind of been away from doing this, and a big reason is I had to make some difficult choices. Um, I found that as I was kind of following along with the stream, I would I had kind of an overly laborious process, is kind of the best way to put it. So I wanted to just get people up to speed with how to do a platform layer for the Mac. By the way, I haven't introduced this character. This is Bishop Julian III, and he's actually a moose, little muss, as we call him. He is also referred to as the Scrum Master in these circles, and so he'll sort of be coaching us along. One reason that I sort of prefer Bishop Julian as the Scrum Master is, for one, he's tiny and he squeaks, which is perhaps drawing some kind of an analogy. I'm not entirely certain, but we need motivation, especially external motivation, and that'll kind of, especially now, this is kind of, I'm recording this pretty late after dicking around with QuickTime and then finally moving to OBS and realizing that it's superior for these sorts of things. So the Scrum Master will be trying to keep me awake as I just finish out what I started this evening, which was to get back into this and sort of try and talk at this camera and get things going. So that being said, here we are. So I'm back, and I've decided to kind of change up how I'm doing things, and for a lot of reasons. So reason number one is I found that I was following along with the series, and I would get to a place where I would write like this like long article, like here's how you do audio, and then I would like follow the stream like 2 or 3 days later on the Mac, and then like I would realize that the thing that I did that I wrote this big article about was totally wrong, and so then I would end up rewriting the article, and then I was thinking about redoing the video, and it just got to be like a ton of rework. And so now the way that I'm thinking about it is quite a bit different. I first thought, okay, well, if I'm frequently wrong, then what it means is I should probably try and get ahead. And before I start kind of telling other people what to do or what things that I think were useful, I should, get 20 days ahead in the stream, or at least finish out the Mac platform layer before I even do another video. And in retrospect, I think this has actually turned out to be a wise decision, largely because I now feel like I can explain it better, but also because in the process of actually just going and building the platform layer, I've discovered all kinds of things and am now just in a better place to actually explain it. So for those of you who were kind of following along, I feel like I've sort of disappointed you. However, now that I have sort of finished the platform layer for the Mac, I feel like I can actually talk about some of these things, and that's overall going to be much better for the educational content. So I just feel like it was a necessary thing to do. I know I delays and whatnot. That said, all of the source code for what I've done to follow along with the platform layer is finished. So I'm on day 34 now of Handmade Hero, and I'm planning to follow the series while kind of working on my own games, just largely because it's really interesting and educational and fun. So that's kind of what I'm doing. There are other people who have done this on the Mac who are much further along than I am. I have no idea how, but Jeff Buck is like all the way caught up with the stream. His platform layer differs from mine in some respects. A big change. Well, there's for one, I'm trying to follow the series very closely, and so I'm sticking with things that Casey does. So one of them is a single translation unit. So really, when building the platform layer, my Mac platform layer is actually just a single .mm file with one main function. We're not trying to have multiple .h's and .m's and translation units for the compiler, largely because I want to be as much in the spirit of the actual series as I possibly can. So that's a difference. But that said, if you are starting right now and you're wondering kind of what to do, I will keep putting out videos, but not necessarily at the kind of pace that Casey does. Got a pretty busy sort of full-time job schedule and etc. But when I do get a chance to actually record, as I have now, when it's nice and quiet here, I go ahead and I do it. So there will be more content, video content coming along, but do think of this kind of as a supplement to the series. The actual series is the code's done. If you wanted to follow along with that, you certainly could. So there's my repository, and then I'm going to actually start a separate GitHub repository that actually does follow along with the videos. So there's going to be one that's like me kind of forging ahead and prototyping, and then there's another that actually kind of goes along with this video series. So that's, I'm trying to eliminate confusion. I hope that in the process I haven't actually created more confusion, but hard to say. So with that kind of said, what I'm trying to do is be a little bit more freewheeling in my approach, because what I've realized is that doing things a little bit more ahead and trying to write so I was writing all this article content and that wasn't really getting much response, and so then I was like, well, that's a waste of time, I'm not going to do that. I'd much rather just do the code and do the video and step through it than kind of get into this writing big long articles that are just really not adding much value. All they're doing is just stepping through all of the textual changes that I did, and frankly I don't find that interesting. And there's also just a ton of that crap on the internet. If you wanted to go and follow some tutorial that's gonna line by line go through this is the change in the code that you do, and now do this change. I'm kind of assuming that this is a more advanced audience. I'm kind of assuming that the sort of people that are watching, the moose aside, maybe does not necessarily indicate the degree of advancedness here. But that said, I think that the kind of person who is more interested in lower level programming probably doesn't really need to have their hands held in the same way that somebody who is just going to slap together a framework and call it a day would. So with that said, this is, I'll try and be mindful of the pace at which changes are made, but I really do just kind of assume that you've already got the source code, you're already following along, and that this is more or less a supplement to whatever it is you're trying to do. So now you can see my screen, and you can see that we've got source code. Last time we left off, we were pretty close to where Casey was in day 4. And what that means is we've got kind of a bit buffer that is displaying to the screen. And we've got, so this is, all this is doing is it's just loading, refreshing a buffer. I made some slight naming change. By the way, I'm going to do some of these kind of changes from time to time. All of these probably need to be uppercase, because I was sort of going along with this more kind of conventions that I'm used to in sort of a separate world of programming that isn't necessarily low level. So I'm going to probably uppercase all of those and rename some of these functions, but that's kind of immaterial to the point. We have a bit buffer that we're drawing. We also have a custom, so if I can run this custom build script. And all that does is it invokes Clang on our one sort of file translation unit that is this OSX main. It builds an executable. The executable makes a buffer that renders this weird gradient, which is kind of like this color sort of offset thing. And we'll just go ahead and take a look at that just so you can see what that looks like. So nothing super special here, just really, so we've got this thing, and you can see what we've got here is we've just got this, we have proven that we can put a bitmap to the screen, and that is pretty cool. So, again, not really invoking any high-level libraries at all, just doing it kind of nice, just going at this with C and sort of with this like infinite while loop that we got going here that just draws the buffer, and then the reason it's animated is because we have this X offset that keeps increasing, and then it sort of overflows, and that's kind of how it gets animated. So, by day 4, or day 5, actually, that's kind of what this is, there's sort of like a time spent kind of cleaning things up. I didn't really feel like there was much need to clean things up. What I do think is it's really important to set up the debugger. So we can use the debugger. We can use debugger from the command line if we want to, which is okay. I sort of tend to prefer to use Xcode for this one thing. Xcode's great for a lot of other things. For this particular sort of series, because we're kind of trying to do it low level without as many external tools as possible most of the time. So first of all, we're not actually going to use Xcode to build the project. We're going to use Xcode only for the debugger. And so it's just kind of a way to be, and the reason is, it's not to say that we couldn't. In fact, we may later use Xcode to build the project if we wanted to, but really what I wanted to do again was to try and be the most in the spirit of the series as I possibly can, and that means not using tools like that. So, or rather, using them very sparsely. So in the series, Casey uses Visual Studio, but really only as a debugger, and so that's kind of what we're going to do here with Xcode. So there is a way to set up Xcode. It's like super old school. A lot of people don't know about it. I actually had to figure it out to do this, where we're actually just going to use it as a debugger. So I will launch Xcode. Again, the reason that you can't actually see my whole screen is largely, okay, this is going to do that. I don't want you to see my projects I'm working on. The reason you can't see my whole screen is because I'm, in using OBS, I'm actually only having it, it's too big of a screen really to record the whole thing without lag, so I'm cordoning off a small section of it. Anyway, there's probably a better way to do it, but this seems okay. So you can't see it, but in Xcode I'm making a new project, so I'm going to make sure that when I do get my project dialog, it's in here. Alright, so most of the time when you're making a new project, you're dumped off here with all these like pre-made app things for different platforms, but actually what we want is just a cross-platform empty application, so nothing at all in there. I'm going to go next. And another really amazing thing about, so usually there's like team dialogue and like, I've got to figure out what team am I on? I've got to do all this like provisioning and code signing just to like run stuff on my own computer. And what's wonderful about this is we don't have to do any of that. So the project, of course, is Handmade Hero, and I just call it Mac platform layer. So you can say that it's a Mac platform layer, useful for platforming, for doing for platforming. So in the Handmade folder, I'm just going to make another folder. I'm going to call it Xcode. It really does not matter where you put this project folder at all. It's just kind of like a thing. And so inside the Xcode folder, I'll create the project. And so now we've got this we've got a project that is associated with the game. And you'll see that there's really just nothing in here at all. And that's actually what you want. Because again, we're not using it to build, we're not using it to do anything other than have it as a debugger. So now I think there's a bit of a sleight of hand, but basically in Xcode you more or less can't do anything unless you make a target for your project. And so what we actually want here is a build scheme, right? So a build scheme will then, or a scheme, I guess you call it that, will allow us to then run the application in the debugger. So the first thing we want to do is make a target, and the target gives us a scheme that allows us to pick an executable that we can then run inside of Xcode and attach to a debugger. Very convenient stuff. So we make a target, and the target we're going to pick is aggregate. So I don't even know why, but I think that's just sort of they used to have this other older school thing, but this is just like kind of the generic one that you pick. Again, don't need a team, no provisioning, no nothing. So this is quite nice, actually. So we're just going to call it Handmade Hero Mac Platform Linear. So finish that. So now we've got a target there, and that's great. But we don't have anything. So we've got this target. Can't really do much here, but we do have a build scheme. And what's kind of cool here is we can go and edit that scheme. And so for running it, if I want to, what I can do is I can have it make an executable for me. So, rather I can have it run an executable. So I'm just going to pick my build directory. Again, where yours is going to be different. So I'm just going to pick my executable here, and I choose that. And I'm going to close this. And now what we've got is we have this thing, and you can even see the little icon there. So what it's going to do is when we click on this play button thing, it'll just run the executable. So let's do that just to make sure that everything's kind of kosher and hooked up. Yeah, not really much to say there. So building it, all right, and we're running it, I think, somewhere. Not sure where we're running it. Oh, come on. Oh, come on! Xcode. No, see, that's not it. Oh. Well, that's strange. Not entirely sure why that happened, but... So we've got the executable, we have that, we can debug it. Doesn't really matter what your build configuration is, this is kind of what we want. All right, let's see if that happens again. Running. Okay. Well, let's see. So we know we have the build, and we know we've got this Xcode folder, and that's got the platform layer in it. One thing I tend to kind of prefer to do is just I want to see if I can get the. Let's slam the code in. So all I did was I just dragged the code into the project, and what I want to see, first of all, when you do this, just if you're going to use Xcode only as a debugger, I would highly recommend not clicking copy items, because if you do that, what's going to happen is it's going to like make a separate copy of that same file, and then it's not really going to be able to link it up for debugging. So what you really want is to just make a pure reference to the file, and then you ought to be able to just put in breakpoints. So I dragged a reference to the file in. Let's see if I can get this thing to like launch. Can we launch? Okay, so we're definitely launching it, and we're definitely stepped into the debugger. Although I'm not really certain why. So inside the debugger, you can see that we've got kind of the screen rectangle. So it's a big screen rectangle. The initial frame for the window. Something's going on there. So that's making our initial frame. Here you can see that it's kind of offset because we wanted the screen window to appear kind of in the same part of in the center of the screen with 1024 by 768. And so we've also we're about to allocate a window. So we go through here, do all this stuff, etc., etc. So we're effectively stepping into the debugger kind of as we would expect. I'm still not really certain why we're not seeing like the visual output. Oh, well, there we go. Okay. So it's there. It's running. Let's see if I quit it. Okay, it's just a matter of like, all right, so one terminal window is in front of another, etc. But anyway, so the game is actually running in a separate window. Sorry, it gets kind of confusing here. And of course, we've got this sort of like infinite while loop. So at any point, I could just chuck a breakpoint in, and we're going to stop there. And so it's kind of like running through and refreshing the renderer. So like I don't know, what's this offset x say, for example. Maybe we can query that parameter. Offset x. Yeah. Not really sure why that's not doing what I want it to do. Huh. I guess offset x is not around here. Anyway, so in any case, you can figure that out later. But many of the original things that we have here that we care about, we're able to step into it in the debugger. So that's pretty cool. This is something that we've totally done from scratch. So if, say, for example, I want to step into the render call that draws the actual buffer, we can do that, and we can kind of step through here. We are totally hooked up and able to have this thing work inside of Xcode, and you'll find this to be a pretty useful thing, largely because, well, I'm not going to say it's impossible, but when I was working on the platform layer and really going through some of the more technical aspects of it, so just kind of give you a little bit of context, there's some, right around like day 20 or so, there's some really kind of crazy cool stuff that happens. So, and another thing that kind of prompted me to sort of like forge ahead before actually finishing, before like really doing more in terms of video, was certain things like, like on day 10, we decided that, or day, I forget exactly, it's like in the teens, we do memory allocation for the game, and the decision is to allocate all of the memory for the game up front. And this is not really something that at the time you're kind of thinking, oh, okay, well, why? But later on, it turns out that there are some really cool things that you end up doing by just allocating all of the game memory up front. And one of those things, as it turns out, is this like really cool kind of playback and record feature that you can use from that. And it turned out to be very helpful for me to be able to step through the debugger, because there are a lot of underlying system calls that were making the app crash for whatever reason. And so if you're just running the application without the debugger attached, or without something that can like kind of help you visualize what's going on, it's just going to be a nightmare to try and throw the platform layer together, to really try and throw anything together. So it's really nice to have this particular feature and have it be kind of convenient and easily doable from your computer. So all I did was I made a Xcode project, and I dragged a file in from the Finder, and I made sure not to copy the file. And now, so if I go back into this build directory, so the reason that we're able to step in and use the debugger is this handmade.dsim file right here that gets created. And the reason that we have that file is because, so back to NeoVim here, the reason that we have that file is because we decided to, I think it's -G, I want to say it's -G. So this flag right here is actually what allows us, what will produce the debug symbols for that executable. So when we set breakpoints in Xcode, it knows to look for that file, and it knows to stop at the breakpoints that are there. So that's pretty cool. In terms of it's relatively late, so I didn't want to make this too long of a stream. This is just more of like a, hey, I'm back. I am hoping to do more content, and I'm happy because I'm actually finished with the platform layer, and I'm kind of on to some other stuff. I'm still following the series because I'm learning a hell of a lot about game development. It's really exciting, and I'm learning all this low-level stuff that I was never exposed to otherwise. But I've also kind of continued on with some other projects, so I'm now trying to kind of play around with my own game prototypes on the Mac. So that's going to be pretty cool. What I'm planning to do is just kind of continue to follow along with the series. That today was just saying, hey, here's how to set up a debugger. But coming up next, I've got kind of this video game controller. So I've got, I tried to be super cheap here and just use my my PlayStation controller. So that's kind of another thing that's pretty cool about doing things low level like this. Is, look, man, if maybe I can like control the saturation. Oh, there we go. It's better color balance. If you are calling into low level stuff like this, I was not able, this PlayStation controller, for example, like there's all these high level like Apple frameworks that like game controller framework does not support this kind of stuff. And so this is just, kind of more sort of ammunition / evidence to the point of, hey, if you want to make something really cool, oftentimes you'll find that you do actually have to step down to a lower level and, go right into those HID calls and figure out how to talk to something like this. And guess what? Like, you can do that. And now, because you know how to do that, you are empowered not to spend a bunch of extra money on some like really fancy kind of wireless controller thingy that, why not? Like, it's like your PlayStation controller is a USB controller. You can totally use that, and you can use it for prototyping, and all you got to do is like know a few extra things, and you're set up, and you just saved yourself like, I don't know, probably $50, maybe $100, but more importantly, you also saved yourself like some really frustrating experience setting up some wireless thing that probably won't work. And so that's pretty cool too. So there's a hell of a lot of value in kind of knowing some of this stuff. That's a bit of a digression, but my point being, next will be video game controller output, and then kind of following up with that, we'll start kind of getting into sound. So platform-specific sound. The Linux tutorial, the David Gao Linux tutorial, actually turned out to be really, really useful for that. Pretty much drew nearly all of my inspiration, or short of like directly copying some code, from that turned out to be really, really quite helpful. So if you're kind of starting to get into that next, I would definitely consider looking into that. So that said, if you're just kind of coming into this and just following along with it, you really have everything that you need if you want to finish the Mac platform layer. There's my code, there's Jeff Buck's code, there's also there's another guy in Salt Lake City. I took a bunch of stuff from him, actually. It turned out to be really useful. That has another platform layer that I'll link to in this video. And so really, you have a ton of options at your disposal for how you want to proceed, and you can proceed at your own pace. You can follow along with the videos. You can just kind of experiment. Send me any questions you might have, which, come to think of it, there's a little bit of time for one of those questions. So one question I got asked, I seem to recall. So you will notice as you are running this thing, so I'm going to turn on my activity monitor just so you get a sense of what's going on here. So OBS is like hogging quite a bit of the CPU, which makes a hell of a lot of sense because it's got to do some fancy stuff. It's got to like capture me talking at the thing. But one thing you'll notice, I'm just going to run this. Just going to run Handmade Hero, and let's see what we get. So it should pretty much, as soon as it's running, like jump straight to the top in terms of CPU usage. Okay. So this thing is like really effing cranking, like crazy. And in fact, I'm gonna select 99% of CPU utilization. That's nuts. Okay, so one of the questions I got asked was, "Gosh, Ted, that seems like a hell of a lot of CPU utilization." And to which my response is, "Yeah, that should be obvious." Well, not totally obvious, but there are some reasons why that is the way that it is. First of all, we're running this application is just one big nonstop while loop fiesta that just goes and goes and goes until we set a Boolean telling it to exit this while loop. So you can imagine, most modern computers, multiple cores and then multiple threads. In some cases, some of the more modern ones, it's like several threads per core. I think in this case, this Mac with a iMac with Retina display is a quad core. It's from 5 years ago. Still a beast of a machine, but there's like one thread per core, so it's got 4 cores, 1 thread per core. This application is running it's a single thread on one core, and all that thread is doing is it's just churning over and over. Like as soon as we draw, so you imagine all it's doing is like we're gonna draw a buffer, and then what we're gonna do is we're gonna like immediately put it to the screen, ask if there's like any kind of keyboard input or anything, and then just do it again and again and again and again. It's pretty obvious that this thing is like churning through CPU as fast as it possibly can. So, imagine like on the CPU there's a scheduler basically that says like I'm going to schedule some work that needs to be done, and whenever some time is free to do some work, this application right here is like hungry for it. It's going to immediately jump in and it's going to keep running this because we're really not telling anything to sleep or stop or do some or wait or do anything else. We've actually just got this thing set up to just totally churn, and that's bad. Obviously, it's obviously not something that we will do in the long term for some pretty good reasons. But that said, what we will do is eventually set this up so that what you have is video sync. And so what we want to do is say, let's say you've got a screen that's refreshing at 120 frames a second, something like that. And what you want to do is you want to time the way that this game draws something to the screen with the refresh rate of the screen. So you would do some multiple of 120. So let's say you would do 60 frames a second or 30 frames a second. That's kind of where these things come from. So if I wanted to draw a picture every 60th of a second, what I would do is I would say, okay, computer, like let's figure out what's the state of the world that I'm trying to draw a picture of. So our made up kind of game world. There are entities within the game world that we update. Okay, and then given kind of what we've done with those entities in our game world, updated them, we figure out what their state is, and we use that to draw a picture of the world. And then what we do is eventually we wait to display that picture. So we wait some period of time, and what we want is for that period of time to sync up with the refresh rate of the screen. So you imagine if we're going like, let's say we're trying to hit 60 frames a second, and that's like 16.6 repeating milliseconds per frame. So in the span of 16.6 repeating milliseconds, what we're doing is at the very start of that, we're going to say, okay, what's the state of the world? Draw a picture / output some sound, okay? And now so now we're looking at the wall clock on the CPU. We're saying, okay, how much time passed? How much time did we spend in the figuring out what's up with the world and drawing some stuff as a result of that / outputting some sound? How much time passed? Okay. Now, take that amount of time that passed and subtract it from our target refresh rate, 16, or target amount of frames per second, or seconds per frame, milliseconds per frame, so 16.6 odd repeating. And the amount that's left over, the amount of time that's left over from that process is the amount of time that we will allow the CPU to rest. So we actually issue, later on in the stream, we actually issue a command to the CPU saying, sleep for the remainder of this time. So if maybe we spent half of that 16.6 milliseconds updating the world and drawing a picture, we hold on to that picture, we still got the picture, then we wait the rest of it, we wait like the other 8 or so odd to a nearly perfect timing. And then right at the moment that that timing is up, then we take our drawn bitmap and we draw it to the screen. So we present it on the screen. And the idea is that this is kind of in lockstep with the refresh rate of the actual monitor. And we can hit that timing more or less perfectly. And there are some people, so obviously like there's a few other sort of technical details that kind of have to go into that. So some of you might say, well, why aren't you using CAV display link? Why aren't you using like a view that say automatically is able to draw for you and is able to figure out the refresh rate of the monitor and sort of do this at 60 frames a second for you? And I agree. That's like what you should be doing. And there are reasons that you would want to do that. And the big thing though is I'm largely doing this for instructional purposes. So if you just use those like kind of higher level tools like a view that just automatically does this kind of rendering in say Cocoa or any of the higher level libraries, you could do that, but you're not really going to get like a kind of a view into actually what's going on. And so the idea is sort of to be intentionally educational and to sort of to step you through how some of this stuff like logically has to work, right? So how does a actual renderer / game engine actually work? Well, it's gotta do this. Like it's gotta update the world and then wait some period of time. There's some small technical details. So something like a CAV display link that you get from Apple's kit it's gonna do some other stuff for you. So one of the things it's gonna do is it's gonna make sure that when you present your picture to the screen, that you're not doing it while the screen is like drawing to itself. So you imagine that like the way these screens work is they're just scanning and like drawing the buffer and drawing the buffer and drawing the buffer. Well, imagine we're at the top of this and we're like halfway through, right? We're like right here, and then all of a sudden like in the middle of drawing to the screen, you've decided, oh, I'm going to put like a new picture there. Okay, so now we were drawing the old picture here, but now we're drawing the new picture, right? And so what ends up happening as a result of that is it looks kind of like a weird video glitch. And kind of the technical term for that is like a screen tear, right? And where does that come from? Well, that comes from because like the top of the screen appears, is a different picture from what's underneath it. And so it looks like the screen is kind of torn in half. So there's other system kind of calls that you want to like, tie into to make sure that you're drawing to the screen at another term for it is called v blank. So you're drawing to the screen at a time when it's in between, refreshing. So ideally, what you want is it's scanning. Okay, now we're not doing it. Draw your swap it out, and now we're going to do it again. So just to kind of get back to the main point, yes, it's quite clear that this thing is just churning through CPU. It's largely for educational purposes, and once we actually get to the part where we're timing things with to get proper video sync, that you're going to see the CPU utilization drop dramatically because we're actually going to be sleeping for the remainder of the frame time. So there's going to be some time spent drawing a picture, and then kind of like this leftover sort of slop that where we need to sleep the processor in order to hit a particular timing. And so that's kind of why you're not seeing that sort of thing going on. So, and again, you know, the idea is to be sort of is to be educational and to also get you to a place where you can follow along with the series. The goal is not necessarily to produce a perfect production-ready sort of Mac platform layer that you could use to make a game that you're going to go put on the App Store tomorrow. The idea is for you to step through this and really understand the entire picture of how a game engine works from start to finish at a low level, and to then be empowered with this knowledge to go and build some cool stuff. So, with that said, so that was the main question I got. Yeah, so I think I can happily end and hope that OBS is working and that this is going. I recorded a full stream, and then it was using QuickTime, and it sucked, and I got about halfway through, and then it like lost my recording, and I got really angry, and then I was like, okay, I'm just gonna do it. And so here I am, and I did it. And the Scrum Master is pleased because I am finishing story points as fast as I possibly can. And so, you know, he's squeaking with glee because we got this done. So, if you would like to, there's Patreon for this that you can support. It's largely Mac-related content that is kind of it's related to Handmade Heroes, so that people on a Mac can follow along. And like I said, my goal is to get to a place where you can follow the series, because I think the series is valuable and it's definitely taught me a lot. I honestly can't even really go into that in enough detail, because I feel like even just I've been following it since last December, so I'm about 9 months of just kind of following it sort of in my spare time. And I have to say, it's certainly opened up a lot of doors in terms of my actual career. The way that I talk about what I do now, because I've invested the time in understanding some of this stuff, is very different from the way that I used to talk before any of this. And so, you know, kind of coming into this, I sort of came into it from a perspective that the typical sort of mobile telephone application, software application developer might typically have, which is one that's more or less informed by the latest gossip and hype and Medium articles from some 20-something kid about how to make a framework thing, do whatever high-level stuff. Just very beginner-oriented and very high-level, and not particularly not deep, not you know, not from a real solid understanding of all the things that are going on under the hood. And so when you speak with that level of confidence, and when you've been there, you know, when you've been to sort of this lower level world, and you're, you know, in technical interviews, for example, or, you know, talking to people at other organizations and etc., finding work, that kind of thing, you know, it does make you stand out. And this is, you know, aside from all of the, like, you know, random, like, you know, textbook data structures and algorithms type problems that you will be assigned. This is, I think it's a kind of, it's in my view, like, that stuff is definitely interesting and something, you know, I plan to kind of get better at. But I've always been the sort of person that I don't like to do things in the abstract. Rather, I like to do things kind of with like a concrete purpose of, I'm going to make this cool thing. And so what's really cool about this series is we're learning fundamental concepts of computing, but with a goal of making something really cool in the process. So it isn't just, hey, here's a binary tree, now what? You know, it's like maybe we'll actually use it to do something cool. So that's kind of why I think the series is interesting and worth following, and why I'm making the Mac platform layer for it so that you can follow along. because I think if you do, and you're interested in this kind of thing, it will only empower you. It will only lead to more career opportunities. It will only make you better at doing this kind of thing. And as a side effect, it's actually really fun. Like, I have to say that this kind of programming, what I find is that when I'm working at a really high level, it gets kind of frustrating because many of the tools just don't let you have, you just don't really have control. You know, say I'm an iOS programmer, and you know, a table view is a table view. It does kind of what it does, and there are certain ways of interacting with it, and you really, when you start to step out of the boundaries of what those are, it gets really frustrating. And a lot of times, you know, you get these designs that like kind of, they want to do something that like would seem obvious or like seem like pretty easy to do, but that, you know, when you actually get down to it, you realize, hey, you know, this high level thing wasn't actually, you know, it seemed like it was like really generic and designed for this like really generic thing, but actually it is relatively narrow in terms of what it can do. And you'll find that kind of thing but when you're working at this low of a level, like if something is not working, like you really only have yourself to blame. You know, like at C, like you working with C directly, what, you didn't draw the bitmap correctly, or you didn't handle like the frame timing or like whatever. So there's something like kind of empowering, but there's also sort of this this kind of like no bullshit thing about it. You know, there's that I really like about it is that, you know, I can come into this and it really is, it's full control over pretty much everything, and I get to choose what direction I kind of want it to go in. I'm not really stuck to some component that was made by somebody else. You know, if we're working with really high level stuff, you sort of have to draw the line at you know, something that somebody else made, and so it just generally is. It's, I think, pretty satisfying to be able to drop down to this low level. And so for those of you kind of coming into it and not really knowing if you should keep following along with it, I can tell you, having finished the platform layer on the Mac, it is totally worth it. And you will come out of it as a stronger programmer, and you will just generally exude a level of confidence in your abilities that you would not have had if you didn't do it. So stick with it. And with that said, me and Scrum Master are going to bed, although when we're scrumming, we never sleep. So we'll see how much rest we actually get.